Thanks for coming to our presentation.
We're Bailey and Tim. Obviously, I'm Tim. This is Bailey. We work at Gaslight in Cincinnati, Ohio, and we're really excited to be here.
Yeah, so Tim is a developer and manager at Gaslight. He's been working at Gaslight for almost 4 years. Tim is very passionate about helping people and is often referred to as the nicest guy in the world around the office. So that's pretty awesome. And so this is not his first ElixirConf. He spoke last year about building an artificial pancreas with nerves. I want to get that right. He's also spoken at Lone Star ElixirConf and CodeMash.
This is Bailey. She is an accomplished designer at Gaslight. She dives really deeply into any of the problems that she's trying to solve. She immerses herself into the domain of everything she does. And she's spoken at the Adobe Creative Jam Conference, and she's a skilled musician and currently pursuing a master's degree in psychology. Very exciting stuff. How many of you have ever heard of Middletown, Ohio? Where did you hear it from? Just from being around there? How many of you have read Ready Player One? So James Halliday, the main character who created Oasis in that book or movie, whichever one you did, is from Middletown, Ohio, and Bailey is too, so that's a claim to fame, I guess. It's kind of exciting. Yeah.
So yeah, so we're here to talk about real-time design. And so why are we both up here? Well, at Gaslight, we really value working together, and me as a designer and Tim as a developer, we really value the different things that we can bring to the table, and yeah, we hope that you can get a lot out of this, even if it might be a little bit different than what you're used to.
So let's talk a little bit about what is real-time. You probably see slides like this on any of these talks if you've done Phoenix Channel's work. I do want to kind of like level set some expectations though really quick. When we're talking about real-time today in this talk, we're not talking about hard real-time. We're not thinking about like GRISP boards or anything like that. It's probably soft real-time depending on how you want to define that. But the important thing is that like nobody dies if any of the stuff that we're doing fails. So we're like totally letting it crash and nobody is getting hurt from that. So it might be soft real-time. I'll let that be an exercise for the listener today. Some examples of real-time applications that we are talking about would be like social media and messaging applications like Twitter or Instagram, collaborative editing apps like Trello or Google Docs, email clients, auction sites, real-time package delivery, live dashboards. I mean, you guys are hopefully, if you've been in the Phoenix ecosystem and watching the channels and presence work and everything like that and using some of that, you're probably already writing real-time apps, and you all have capabilities that are available to you through Phoenix that you may have never had before. So that's the kind of thing that we're talking about today. All these affordances that we now have with the ecosystem and the infrastructure that Phoenix gives us, we now have new challenges that are ahead of us. So any kind of system where the data could change out from underneath you frequently, now you have some different things to take into account. It's constantly in motion, and you can't really ignore it anymore and give people static views into a system that's constantly changing. So for a long time, we didn't have things like Phoenix channels. Now that we do, we have to use them wisely. So this talk is mostly about how to cope with changing data and some of the things that we found across the board as we talked about it within Gaslight on the projects that we were working on.
Yeah. So I'm going to ask a question. Are there any UX designers in the room? Oh, did I see a hand? Maybe?
Yeah. All right.
Sweet.
Yeah.
You? Yes, awesome. That makes me feel a lot less alone. What about, how many of you have worked with a UX designer, like closely? Hey, okay, cool. Would anyone like to provide a definition of what they think UX design is? Anyone?
One brave soul. We just need one brave soul.
Oh.
Removing the software from the experience.
Ooh.
That's
Your application from the experience is something that they're just, they don't have to know anything about technology. They just, same way we make phone calls. We don't care what's in between. You just want a number that works.
Yeah, I really like that definition. Let's like put that on this slide instead of this one.
Live edit it real quick.
That's awkward. Yeah, that one's a lot better. this is the definition I came up with, just the process by which a designer determines what the intended user experience of a digital product will be. So UX designers are in a pretty unique position. They have their roots in the design world, but they have to live in the digital world, where many designers, such as graphic designers, also inhabit the digital world. UX designers have to deal with completely different constraints. So they often work closely with developers, like we work at Gaslight, and they have to be realists, but also dreamers. So they have feet in two different places. So they borrow from the artistic and the technical. Many designers have formal design backgrounds, but a lot of different UX designers have a variety of different backgrounds. I have a mix of both technical background and an artistic background. So yeah. The term UX designer can also often mean so many things. It's pretty hard to define, maybe mostly because it's a new career path. Two UX designers can have the same title at two different places, but they might do totally different things depending on where they work. So that can be pretty confusing. At a bigger company, UX design roles might be split into different roles, like UX designer, UI designer, visual designer, graphic designer, or UX designer could be like a more umbrella term where they're a jack of all trades. So these are some of the day-to-day UX design responsibilities, at least with how we work at Gaslight. So the UX designer will do a lot of research on the product that's being built. They will build out personas to get an idea of the ideal user for the product. They'll consult with the client, depending on where they work. They'll make wireframes and mock-ups for the product to kind of get an idea of what it should look like before everybody starts coding it and building it out. And they might do the branding and design of visual assets. They'll make user flows to get the team on the same page and hash out what the information architecture should be. They'll also do user testing throughout the process of building the application. That's a really important part of it, so that you can validate the process iteratively.
It's a hard word.
And some UX designers might even do coding. I know I do, but some UX designers don't. It just depends. And that usually involves HTML and CSS and maybe a little bit of JavaScript if you're crazy. And then another big thing is the need to understand development needs and concerns, since as a UX designer, you'll need to work closely with developers, like most of you. And yeah.
So as a developer on the team working with a UX designer, you might wonder, like, why does this really matter to me that much? If you're anything like me, okay, so when you're writing Elixir code, are you like, do you get a weird, like, joyful feeling when you're typing Elixir code into the computer, or is that just me? Like, there's something about Elixir. I mean, I felt it a little bit with Ruby as well, but like, you feel connected to the code that you're writing. You're not like using autocomplete to like build these method names that are super, super long and stuff like that. You actually feel like there's something you're crafting. And so I'm excited about code. I love to write code that solves problems. I love to write code that solves problems that I shouldn't write code to solve problems for. Like, there's a lot of people problems and domain problems that I just don't think that code is the right solution for, but I still like to write code for it, which means that sometimes I write code to fix problems that I wrote code for. So, it's kind of confusing because I just really like to, as a developer, try to use my skills as well as I can. And one of the ways that I can do that best is to step out of the problem from a code perspective and to think about it from a design perspective. And in fact, I think you had a really good definition. It was like taking the app away from the user experience, like taking the implementation of the technology away from what it is that they're actually experiencing. That's a really good way to put it. You're putting the focus on the usability first, and whatever technology you need to implement in order to make that happen is good. So usability from a design perspective is great for developers. And just like when we do test-driven development, and we use test-driven development to guide the design of our architecture and our systems, using usability first, like putting focus on usability first, allows us to design a system that is user-centric rather than code-centric.
All right, so switching gears before we get to some of the meat of what we're going to talk about, let's take a second to consider like how we got here. So the web used to be a lot more document-like because that's where we've gotten our inspiration for where the web came from. We're used to paper and traditional media. But more recently, it's evolved to be something much more dynamic and interactive. So now we build experiences instead of things that just imitate paper and things like that. So through building real-time software at Gaslight across many different domains, we've encountered some common problems specific to real-time design. And we interviewed a few teams at Gaslight and gathered the research into some common real-time pitfalls and tips. So we'd like to share those with you today, and hopefully they are useful.
So this first one might seem a little bit oddly specific. It's sort of a subtype of a larger problem of when you have a real-time system and there's a lot of data coming in all at once, showing that information in a list to somebody when that's appropriate is really difficult. And one of the things that we encountered across several of our projects that we were working on was paging. And paging is kind of, it felt to me when we walked into these real-time applications like I understood it and I had a solution for the problem. And it turns out that that wasn't right. I wasn't really thinking about paging correctly. If you have done paging, you're probably used to the traditional style of just using an offset. And in that offset, you might be thinking something like, okay, so I have a page size of like 3. I want to be on page 1. And if you actually look at the code, I don't know if that's large enough for you to read, but this is basically from the Ecto query pages, so the API documentation. I added a little bit more in there just to kind of make it more applicable, like the ordering of new things coming in is usually what you want in a real-time system. So if I'm a user of a real-time system and I want to see new information, I probably want to see that at the top. So, but other than that, it's basically straight from Ecto query. And it looks like it's going to work really well, right? I pass in page 1 and I have a page size of 3, I'll see the green. Sorry if you're colorblind, I didn't make these very good for colorblind people. If you look at page 2, you'll see the yellow there. So everything looks great, but let me kind of mess with your mental model of this paging for a minute, and let's think about real time. If you go to the next page in the system, but new things have come in, like let's just pretend the 2 red rows at the top are new data that came in while the user was looking at page 1. What is it that they're going to see if they go to the next page? Well, they're actually going to see 2 things that they've already seen if they go to page 2, because they already saw those pages, but things moved them down. This is a bad time, because if they notice it, then they lose trust in you as a developer, like building the system for them. If they don't notice it, they might be making decisions based off of bad or stale data. So that's kind of something that we had to take into account when we were doing these systems. I'll step back here for a second. Where we saw this the most was actually on a project called POA. They were here as a platinum sponsor. They just talked at the beginning of this, and it's a side chain of Ethereum, so I'll just give a little bit of an overview of that and why it kind of matters for what we're talking about today. But the idea is that if you don't know anything about blockchains, it's essentially an open ledger. There's these blocks that get mined or validated and put into the chain, and they depend on previous blocks being there. So the way that it validates is that it builds on itself. They hold transactions, they hold things called smart contracts and addresses where things go from and to, and so you can basically transfer coins or tokens or actually sometimes like skins in games. There's a lot of really interesting stuff going on there with that. But basically what you need to know is that there's always transactions coming in. On POA, they're trying to do every 5 seconds, like a new block comes in with potentially hundreds of transactions in each one of those things. So paging became a little bit interesting for us on this application because we were trying to figure out how do we both slide in real-time information as it comes in, but also give them the user access to older information as we're building Block Scout, which is the explorer that goes into the blockchain that basically reads from the blockchain and gives you a view into what's going on inside of it. So when we were kind of trying to think about this problem, there's some ways to solve it. Jimmy at our company on the project had introduced me to an idea called last seen paging. The idea is basically you can't use offset anymore because offset is just going to offset you from the top of the results. You have to use a paging mechanism that sort of moves along with the data. You have to have an anchor point within the data that you've looked at already so that when you go to the next page, you see the relevant data that you're looking for. So let's kind of look at what that looks like if we fix this ecto query to understand relative positioning anchoring to timestamps. We get rid of the offset, and then we add in this, this additional where clause, which basically says, I'm going to offset from something that I've already seen before. So the user, relative to the context of what they were looking at previously, sees the right data on the next page. And then what you get is basically the correct paging there. That was, it seems a little bit oddly specific maybe to start out with this, but it was strange because it kind of came back over and over again on the different projects that we talked about and the interviews that we did with the teams. So it seems like a good thing to start with here. One of the interesting things that this gives you when you're doing it like this is it actually opens up other possibilities to you. Like you kind of saw in that animation, you can slide new things in at the top, and it's not a jarring experience because they're not seeing like chunks of data. They're actually seeing like a living page of new things coming in. You can also implement something like infinite scroll, like Twitter does, where you get to the bottom and you can kind of perceive that the user's going to need more data soon, and you take paging away from them completely. They don't even have to think about the fact that they're going back in time and looking at older stuff. The page is just doing that for them. So this approach kind of gives you a little bit better opportunity to implement some other more novel approaches rather than just clicking older and newer or page 1, page 2, page 3. There is one subtle part in here that I want to point out, and we found this. If you actually fetch one more than the size of the page that you're looking for, you don't have to do an additional query to figure out if you should show an older button for more older results. You can just show the 50 results, but if there is that 51st result, you know there's older data, you can show a button there. So just one of those little tricks that we learned along the way and we've used pretty regularly.
Yeah. So the second thing that we've come across when thinking about real-time design is communication and consistency. So when you choose to make an app in real time, it's important to go all in. This is where establishing user trust is super important. So another big problem that the POA team has had to solve is how to be consistent with the communication of real-time changes in the app. So you can't go half in real time and have half real-time data and half static data because the user doesn't always know the difference. You need to give them the benefit of the doubt. So it's important to establish trust there. So in a world where everything is in real time, it can be pretty jarring when something isn't these days. So this is another screenshot from the POA project. So on the top you've got blocks, and on the bottom you have transactions. So the POA team has done a great job of making sure that the UI is consistent and that all the data that could be in real time is being communicated in real time. So for example, if the transitions and blocks were sliding in real time, but the age in seconds, which you can see like on the blocks, was not updating in real time, that would be pretty off-putting to the user, and they wouldn't know which one to trust. So it's important to always compare what's actually happening with what the user expects to happen. And to do that, you really have to get in the shoes of the user and interview them, do user testing, and really communicate with them and empathize with them.
So just kind of a practical example of how this might work. Bailey mentioned that when new blocks come in, you can kind of see the age of how old they are. It turns out in the blockchain, age of things really matters. It also matters for other apps that we're going to talk about here in a few minutes. But whenever you're going to show how old something is on the page, that's changing constantly because time is moving forward. And so sometimes the perception of having real-time data is as important as having the real-time data. We're not going to update the entire page every second from the server, but if there's data that looks like it's stale compared to data that just came in real time, that's a jarring experience. We lose the user's trust. So just kind of a quick example of something that you could do if you have time age data is just basically build this is a raw web component. You could use React or something like that as well, but just putting an element on the page that has a little JavaScript to back it up, looks for the attribute of the timestamp, and then uses moment or something like that to figure out how old that thing really is and show it in a human readable way so that people can see a minute ago, an hour ago, and if they come back to that page in a day, it says a day ago. It's updating essentially live, but it's all happening on the client side and giving them the perception and the trust because the real-time system is consistent across the whole thing.
So one example that everyone in the room has probably dealt with is GitHub. So when you create a new repository on GitHub, clone it and push code, the page doesn't seem to update. You get the page that you see in this tweet right here. But when you're exploring the rest of GitHub, a lot of the stuff updates in real time, like what are some examples?
Like comments on PRs,
Yeah.
if somebody merges a branch, all that kind of like flows in behind the scenes. It's just this first page when you create a new repo and you push new code to it. I've sat there staring at it for like half a minute before, like, okay, refresh. I push code up, it should be there.
Yeah, so it can be pretty disorienting. And that's a good example of where consistency comes in, and how if something isn't in real time but you expect it to be as a user, you kind of lose your trust. And maybe you don't lose all your trust in GitHub as an organization, but you're kind of like, man, this kind of sucks. So the third thing we're going to talk about is animations and transitions. This is an important part of UX design as a whole, but especially if your application is in real time. So transitions are really helpful to show change, and with that, animations, which are kind of interchangeable depending on how you're considering them. So with this, though, it's very important to consider how the real world works. So when we're looking at things that are moving, they move gently. They don't hop from place to place instantly. Because we blink and we like to see subtle changes. So when you're thinking about the design of things and how they change, it's important to put in some easing and transition so that users can see when some real-time data has been updated or removed or added.
One of the things that one of our designers, Ryan, said when we interviewed that team, he said, you want to know how you got somewhere. So if you're at a starting point and you jump immediately to the end point and you don't see a transition between them, it's a jarring experience. You want to see how you got from one part to another. So whatever you can do to ease that transition for the user's mind helps them to keep their mental model alive of what's going on in the system.
And with that, in the real world, there's acceleration and deceleration. So while there are periods of movement from one point to another, it's not at the same speed all the time. So that's another thing that can be kind of fun when you're thinking about animations. So this is another screenshot from the POA project. And the designers, Ryan and Katie from Gaslight, did an excellent job of animating it. So when new blocks come in, they not only come in from the left and like ease, but it's just like, it kind of mimics what blocks look like, or what you would imagine that they would look like if they were real in the real world. And it's great because they didn't overuse transitions. So while it can be fun and cool looking, you don't want to overwhelm the user because that kind of defeats the purpose. So this is some CSS code that you can use to implement some simple transitions. In CSS, there are 4 transition properties. They can be written separately, like the above block, or they can be combined into a shorthand. It's usually best practice to combine them into a shorthand because it's easier to write and simpler to look at. So there's transition property, which is the CSS property that you're wishing to transition. There's transition duration, which is self-explanatory. The timing function, which you can get really creative with and really fine-tune it. And then there's the transition delay, which is how much time you want to wait before the transition happens. Going back to the timing function, you can use linear, ease, ease in, ease out, or use a cubic Bezier function. And if you Google those, there's some pretty good resources for that. But so here are some of the other timing functions that you get out of CSS. And these are from easings.net, which is a good resource for that. So in CSS, transitions is one thing, which is what we just talked about. But animations are another property. And it can be kind of confusing when you're writing it. So like, I'm usually like, what is a transition and what is an animation? So technically, transitions are animations, just with 2 steps, so going from point A to point B. But if you want to fine-tune your transition, you can use an animation property. So how you do that is, on the right block, there's a keyframes rule, and it's called fade up. And you'll see 0%, which is the beginning of the animation, 25%, which is a quarter way through the animation, and then on to 100%, which is the end. So at each of those steps, that's where you specify the different properties and values for the things that you're animating. And then in the left block, there's the animation CSS property that is calling upon that rule that you defined.
So kind of moving on to a new topic, we want to introduce another case study just as an example for what you might run into. But we want to talk a little bit about the real world and its data when we're talking about real-time applications, because sometimes you're a little bit lucky in the data that you're dealing with and it actually maps to physical properties of the real world, and you can actually model that in a way that the user already has a frame of reference for. So I want to talk for just a second about Bus Detective. Bus Detective is actually an application that Gaslight's had for a while. It's a transit application for real-time tracking of buses. It started out just basically in Cincinnati. It uses the GTFS protocol, so the GTFS file specification, which is General Transit File Spec. If you live in a major city that has mass transit, they probably follow this specification at this point, because that's how you get into maps.google.com, and you can like find a way that's an alternate path than just like driving yourself to another location. So it has these layers of architecture. It has scheduled data that doesn't change very often. It might change every day. It has real-time information about trip updates that are happening. So when is a particular bus going to be at a particular stop? And it also has real-time vehicle positions. And it will tell you, like, if there's a bus that's on the road, it'll actually, you can plot that on a real map. Just a little background on the architecture of this application. If you want to use it for a reference, that's cool. Block Scout, there's links in the Whova app after this is over if you want to look at those and understand and read some of the code there. But basically, it's just a couple of backends. They're their own Elixir applications within an umbrella. They run on their own, and they use the registry to do a single node sort of pub-sub thing. That's basically straight out of the Elixir documentation. So if you want to do that yourself, you can do that. And then on the front end, there's something that basically pulls that information when it's sent and then sends it over Phoenix channels, and the client gets the real-time updates. So I kind of just want to give a quick little live demo if the internet is going to play along here. Click the wrong thing. Oh, I don't think I can click.
We might have to.
All right. That's fine. All right, so it's not up there. All right, I got to figure out which.
Oh, there it is.
Okay, cool. Yeah, first try. This is in honor of ElixirConf2018. This is actually Seattle Bus Detective. We wanted to try it out on another set of data and see what would happen. So this is the real-time transit app for Seattle, seattle.busdetective.com. No, we didn't write it just for this specific conference, but it is kind of a cool measure. So we're going to leave that up this week. If you guys end up going into the city, then you can use that and track it against what actual buses are moving through stops and things like that. Some of the interesting things here is you can see the shape of the trip that these buses are going on. You can see the bus numbers as they move. And you can also see the real-time information below it of when the trip updates are expected to appear. And one of the cool things about this is that if you don't trust the bottom part of the screen, you can actually look at the top part of the screen and see the actual bus and when it's going to arrive. Sometimes mass transit systems aren't the best at predicting things. And so it's nice to be able to see those things, especially when they work together, and the dissonance when they don't let you evaluate it and make a decision as a user what's going on. So this is an example of when you have real-time data and you can map it to something that people already understand, like a physical location on a map or a real bus that they're about to get on or the stop that they're sitting at. Do that whenever you can, because people can use mental models and understand what your application is telling them more easily than if we put like latitude, longitude points or something up on the map. So. Now I've got to get this thing back over here. There we go. All right, we kind of briefly touched on it, and I'll touch on it again. One of the ideas also is that if you can, it's not quite skeuomorphism, maybe it is, but if you can relate the information to their mental model in a different way, do that. Block Scout's a good example. You actually see blocks kind of coming in and chaining together and pushing the older data away. That fits with people's mental models of how blockchains work at a high level. And so if you can kind of model on the screen visually what people are seeing inside their head, then there's like, they can make a connection with the data that they're seeing much more quickly, and it doesn't feel like it's a brand new way of looking at it. Also, I don't think I have a screenshot of it, but when data comes in too fast, for somebody to be able to see it. Like if there were 1,000 transactions that came in the same block, it's useful sometimes to do kind of like what Twitter does. If you get too many notifications, they'll tell you if you got like 10 new tweets, and give them an option to like filter through and read the things that they're looking at, so you're not pulling their attention away to every new thing that comes in. Give the user an ability to make the decision when they want to see that new information come in. That's another good thing that you can use as a technique.
Yeah. So we just have a few more UX design practices we want to share, but first one is information hierarchy. So real-time apps are viable to change in real time. So that means that you need to think a lot about the hierarchy of information and how the information is presented on the screen, which is a heavy design problem. So the design needs to make that information skimmable, and it needs to make sense in the context of the problem that you're solving. So a lot of websites these days are still kind of like paper, form-like or static, but in real-time data, the form-like approach becomes kind of irrelevant and can even hinder the design and user experience significantly. So with that, when you're designing a real-time application, you might need to look for inspiration in different places that you usually wouldn't look. So talking about that, here is a screenshot of another project we've been working on at Gaslight recently. It's called ElixirConf2018 Marine, and it's a platform wherein marine shipping companies can bid on fuel. So in this, it's a very high-stakes thing. So people are bidding on very high-priced auctions, and time is a big issue. So the things that are more likely to change usually need to be higher in the information hierarchy because they're more important and the user cares about them a lot more. When data is updating in real time, it can free up a lot of space because things are swapping in and out and don't need to all be on this page at once. So you no longer need as many pages or even screen space. But with that, that adds another problem, and that is how do we show all of the complexity in a clear way? It feels like it pushes you away from the traditional form-based approach. So when we talked to the designer of this application, she voiced the importance of looking for inspiration outside of just websites. She said that they even looked for inspiration on plane dashboards and things like that. Things in the real world, which can be pretty exciting if you're a UX designer and you're used to just browsing Dribbble or Pinterest or something of just websites and inspiration there. So it can be an interesting way to integrate the web with the real world. And here's another screenshot of the same application, kind of going along those lines. So the final thing we're going to talk about is connectivity. So users need to be notified if the data that they're seeing is stale or if they've encountered a connectivity issue and they're no longer connected to Wi-Fi. Connection problems and time problems are design problems that need to be solved, not just development problems. So if you're disconnected and you connect again, the system needs to tell you that you're catching up. If something goes online, if you go online and then come back, that might mean that you need to replay the events that they missed or show them in a meaningful way that makes sense for the problem. So this is what the connectivity status looks like in Ocean Connect that you saw a few slides ago. So since it's such high stakes in Ocean Connect, they decided to show the connectivity status constantly. So it's green if you're online and red if you're offline. So that's a pretty good way to instill confidence with users and get their trust. And this also draws inspiration from the Wi-Fi symbol that you're used to seeing. So it may be important for you, if you're designing an application, to think about things that users are already used to seeing and how they integrate with the problem that you're trying to solve.
I can talk about this one a little bit, just because of the Block Scout project I'm on. Sometimes it doesn't really matter as much if there's a connectivity problem. Like when you're talking about an auction, you need to know, like right now, if you're going to lose that auction, or if you don't know that you're going to lose it because you've lost connectivity. In the example of like Block Scout, where it's basically a view into a blockchain, but it's not modifying the blockchain directly, Or like with Bus Detective, where there's not a whole lot that you're not gonna change a lot about the decision making that you're gonna make if you haven't seen the last 30 seconds of data from it. Sometimes it's appropriate just to give a relevant, contextually, like visually near the problem kind of a message, and then just let the user make a decision from there. Like they may not actually care that you're disconnected right now because they're not looking for anything new to come in. So just giving people a message that's context sensitive to what they're looking for and giving them the option to make some kind of action happen, like clicking a button to refresh or whatever. Sometimes that's enough. So it's really important to think about the problem space that you're in and how important it is that you know that like Phoenix presence is there and that they're disconnected or that they're connected. It's just kind of, it's not ad hoc, but you need to think about the problem domain before you actually try to solve that problem. All right, so to recap, we're a little bit over on time, I think, but to recap, the things that we want you to know about today that are important, paging and just showing lists of information, that's kind of different in a real-time system, and you kind of need to think about how to choose a strategy wisely that takes into account the fact that underlying what they're seeing on the page right now, there's a lot of changing data that could be happening, and you want to build a good user experience around notifying users of new information that way.
Yeah, so second was communication and consistency. So when you choose to make an app that is in real time, it's important to go all in and not have half real-time data, half static data, so that you can establish user trust.
When you're talking about easing information in so that people understand where they go, like animations and transitions are your best friend. They're also your worst enemy if you overuse them and make the users angry at you.
Or just hate CSS.
But you don't want changes to happen in a blink of an eye if you can at all help the user get from point A to point B smoothly.
Yeah. And then information hierarchy. You might need to look for inspiration in places where you're not used to if you're a designer in a real-time application. And it's important to make the page skimmable and think about how the real-time data is making the user experience design different than what it would usually be if it was static data.
And finally, connectivity. You need to think about it in terms of the domain of your problem is really the takeaway for that one. But basically, you want to be able to communicate to the user and them to be confident in the data that they're seeing. And if it's stale data and they don't know it, they're going to lose trust and you're going to lose their trust. So basically, the overarching theme here is like do the things that help people understand what it is that's going to give them the best information to make a decision and keep their trust by giving them a consistent, good experience.
Yeah. So I think that's all we have. Hopefully this has been interesting and useful to you, even though it might have been kind of different than what you're used to seeing at ElixirConf. I don't know if we have time for questions.
I do want to do a little plug really quick. We're hiring designers and developers regularly at Gaslight. If the kind of projects that we talked about here and the kind of concerns that we think about and how we work together are interesting to you, come see me, come see Bailey. And also, James Smith is giving a talk on event sourcing later on Friday tomorrow. So he's going to talk about Ocean Connect Marine a little bit more in terms of how to build an auction site in Elixir and do it well so that you can audit everything that happens and understand everything that's going on there. So,
yeah. And we also have a booth out there.
Yeah, we have a booth out there,
so
and if you like coffee, there's an espresso
yeah.
booth with a barista. So.
Yeah.
Are there any questions? Okay.
Cool.
Then, thank you.
Thank you.